Hey everyone, tomorrow we will be taking our Unit 1A Systems of Equations test. So today we're going to be doing our review over that topic. On your paper, it should be an examples column and a practice column. In this video, I'm going to go over all of the problems on the example side, leaving the practice problems for you guys to practice on your own. So let's look at number 1 on our examples. How many solutions does the following system represent? Explain. So a system is two or more equations that work together. The solution is always going to be the point that makes all three of the equations true. So in this case, we have planes representing each equation. The blue plane is one equation, the pink plane is the second equation, and then the yellow plane is the third equation. So you're looking to see where all three of them intersect. If you look closely, they intersect at a line right down the middle, just like that. So then you have to think to yourself, how many points are on a line? So I know that a lot of us are in geometry or have taken geometry before. A line is made up of infinitely many points. Therefore, this system has infinite solutions. So infinite solutions because all three planes meet at a line. Okay, example number 2. Solve the following system using elimination. So this system is a 2 by 2 system, meaning that there's two variables and two equations. Using elimination, we need one of the variables to have a common coefficient. So the x's have different coefficients, the y's have different coefficients, but we can fix that. So I'm going to label the top equation as equation 1 and the bottom equation as equation 2. The simplest way that I find is I look for one of the variables that has nothing in front of it, so this one right here, and I just make it the same as the one below it. So I need there to be a 7 here. So what we're going to do is we're going to take equation 1 and we're going to multiply it by 7. And then once we do that, we're going to add it to equation 2. So that's the first step that we need to do. Okay, so what actually is that first equation when we multiply by 7? So 7 times 5 is 35. 7 times invisible y is just 7. So far I have 35x plus 7y equals, and then 7 times 9 is 63. Bottom equation, we're not multiplying it by anything, so I'm just going to rewrite what we already have. Okay, and then we said our strategy was that we are going to add these two things together. So that gives me 45x, the y's get eliminated, equals 45. We're almost done finding x. We just don't want there to be a coefficient, so we are going to divide both sides of this by 45, which gives us x equals 1. Okay, but now we need to go and we need to find the second variable. So right here for our step, I'm going to say plug into. Okay, so we have equation 1 or equation 2. Either will work. I usually pick the one that has smaller numbers, so I'm going to plug into equation 1. So that is 5x, so I'm leaving a space where the x is at, plus y equals 9. And I'm going to plug in the 1 that we just figured out from right here. So this one is going right into there. 5 times 1 is still 5. So 5 plus y equals 9. And if I want that y to be by itself, we're going to subtract 5 from both sides, and that gives us y equals 4. So just be careful when you're writing your final answer. You want it as an ordered pair, and it's always alphabetical order, x comma y. So our answer here would be 1 comma 4. Okay, example number 3. Is the order triple 048 a solution to the following system? Why or why not? So remember example number 1 that we just finished doing. The solution is a point that makes all 3 equations true. So what we're going to need to check is that order triple that I just highlighted, which is x, y, z, doesn't make every single one of these equations true. So I'm going to label them again, equations 1, 2, and 3. So let's start with equation 1. We have 4x plus 4y plus z equals 24. So notice that everywhere that there was a variable, I just kind of left myself a space. And now I'm going to go plug in our numbers, 0, 4, 8. So the good thing about x being 0 in this case is that means that that first little portion I don't even need to do because 4 times 0 is 0. So I have left 16 plus 8, and if I'm doing my math right, that does equal 24. So this is a true statement. I'm going to write T next to it. That's true. Okay, but it's not enough for just one equation. It has to work for all 3. So now let's look at equation number 2. And that one is 2x minus 4y plus z equals 0. And then I'm going to plug in the order triple they gave us, 0, 4, 8. Again, that first portion, I'm just going to ignore it. So now I have negative 16 plus 8 equals 0. So negative numbers, it's almost like subtracting. So 8 minus 16 would give me negative 8. And that's not true. Negative 8 is not equal to 0. They are 2 different numbers. So that is false. So if you super wanted to, you could do the third equation again. But at this point, why bother? As soon as one of them is false, then that means that that order triple is not a solution. So let's write that down. So 0, 4, 8 is not a solution because it makes at least one equation false. So notice how I said at least one. It might be 2. I didn't check the last equation. So at least one of them is false, so it's not a solution. Okay, example 4. Now we're going to start solving a 3-variable system. So 3 equations, 3 letters. So it gets a little bit tougher. It's not super difficult, it's just very tedious, so it's super important that you keep everything organized. So I'm going to start by numbering my equations. So equation 1, 2, and 3. And in this case, you want to look for the one that looks the simplest, like which one is the easiest one to solve. And in my case, I think that equation number 2 is the easiest to solve because I could just do negative 9x equals negative 63. If I want x to be by itself, we're going to divide by negative 9 on both sides. And that gives me x equals positive 7. So boom, I already have one of the variables. Now looking at the 2 that are left over, so equation 1 and equation 3, equation 1 now looks like it might be a little bit easier to solve because I have 1 out of the 2 variables that are there. So now let's look at equation 1, and that one is 3x, so I'm going to leave a space where the x is at, plus 6z equals negative 3, and we're going to plug in 7 since we just figured out from above that x is 7. This now leaves me with 21 plus 6z equals negative 3. I have a 2-step equation here. Let's subtract 21 from both sides. 6z is equal to negative 24. And then just one more step. If I divide both sides by 6, z is now equal to negative 4. So now I have a second variable. So I have two of them so far. The only one that I'm missing is y. And the only equation that I haven't done is that third equation. And if you look at it, like that's the only one that has y. So I'm going to have to use that. So our last step is to get equation 3 and plug in any of the variables that we already know. So 4x, we know what x is, so I'm going to leave a little space there, minus 8y plus 3z, and we also know what z is, so I'm going to leave space there, equals 24. Okay, then for x, we know that that's 7, so I'm getting that from here, just plugging it in. And then for z, we know that that's negative 4, so we're going to plug that in. Okay, so then this leaves me with 28 minus 8y minus 12 equals 24. Negative 8y, I'm going to go ahead and combine my like terms. So 28 minus 12 would give me 16. We're trying to isolate the y, so let's subtract 16 from both sides. I now have negative 8y equals 8. And if we divide by negative 8, y equals negative 1. Okay, and I officially have all three of my variables, x, z, and y. Just make sure when you write down your final answer, you put them in the correct order, always alphabetical. So this is going to be 7, 1, negative 4. That is our ordered triple. Okay, number 5 is another 3-variable, 3-equation system, only this one is a little bit more work because notice that all three of the equations have all three of the variables. So in this case, we're going to have to use elimination. So I'm going to number my equations off just because I want to make sure we stay organized. So what we're looking for is a variable that has the same coefficient in 2 or more of the equations. So if I look down the x's, 2 of them have a 4, so x might be a good variable to eliminate, but let's still look at the others. If I look at the y's, all 3 of them are different, so definitely not the y's. And then if I look at the z's, I have 2 of them that have a 4, so z is also a good option for elimination. So it's between the x's and the z's on which one I should eliminate first. I'm going to go for the z's only because the 2 that are the same, so see how they're both 4? One's positive and one's negative, so that means that it's pretty much set up for me already. So first step that I'm going to take is I'm going to get equation 1 and I'm going to add it to equation 3. Equation 1 is 4x minus 4y plus 4z equals negative 4. And equation 3 is negative 3x minus 3y minus 4z equals negative 16. And now we're going to add these two things together. This gives me 1x, or I'm just going to write x, minus 7y. The z's get eliminated, equals negative 20. Okay, so I was able to eliminate z, so now it's just a 2-variable equation. I still need to do more, but I need to save that equation. It is important. So I'm going to save this as equation A. I'm going to put an A next to it. Okay, so now I need to take a different combination. So I can't do 1 and 3 anymore. I could do either 1 and 2, or I could do 2 and 3, but I need to eliminate the same variable. So I need to eliminate z again. And I think we should use 1 and 2 because looking at those z's, one is positive and one's negative. But all I'm going to have to do is multiply that second one by 2. So my next step here is I'm going to get equation number 1. And then equation number 2, I'm going to multiply it by 2. And then I'm going to add them together. So regular equation 1, but equation 2 we're going to multiply by 2. Okay, so I'm going to rewrite equation 1. 4x minus 4y plus 4z equals negative 4. And then equation 2, if we multiply everything by 2, I would get 8x plus 2y minus 4z equals 10. And now we're going to add these two things together, leave me with 12x minus 2y equals 6. And this will now become my equation B. So now what we want to do is we want to take equation A and equation B, and we want to solve it like a normal two-variable system. We know how to use elimination or substitution. We're going to need to do that. Since I see that this x is by itself, I think it's going to be easiest to get this top equation and multiply by 12. Okay, so for this step, we're going to do 12 times equation A, and then equation B, we're going to leave it as is, and then we're going to add these together. So actually, before I mess up, this is positive 12, so I want this one to be a negative 12, so I'm going to multiply by negative 12, and then I could add them up. Okay, so this equation right here, if I multiply everything by negative 12, it's going to become negative 12x. Then the double negative is going to make this a positive 84y equals, then again, another double negative is going to make this a positive 240. And then equation B, we're just going to leave it as is. I'm just rewriting it. Okay, now let's add these together. Those x's will get eliminated. And I'm left with 82y is equal to 234. Oh, I'm sorry, I'm subtracting. That's why it took me a second. I needed to add. So this is 246. I'm sure you guys saw that. Okay, and then now if we divide by 82, we get y equals 3. Okay, so that is the hard part. As soon as you can get one variable, the other two come kind of faster just because they're easier to solve using substitution. So since I know that y is 3, using either equation A or equation B, one of these two, I'm going to plug in my 3, that way I can solve for x. I like using the one with smaller numbers, so let's use equation A. So for this step, I'm going to say plug into equation A. So plug into A. We would have x minus 7. And then I'm going to leave a space because we know what y is. Y is 3 equals negative 20. So x minus 21 equals negative 20. And if I add 21 to both sides, x equals positive 1. Okay, and now that I have x and y, I'm going to go back to my original 3, so 1, 2, 3, and plug into one of those to get my last variable. Looking at those, they all kind of look the same, to be honest. I'm going to use equation 2. Yeah, and let's work that up here. That way we can look at our equations. So last step is to plug into 2. Okay, so 4x, but we have a number for x, so I'm leaving a space, plus y. We also have that, so I'm leaving a space, minus 2z equals 5. Now we got that x is 1 and y is 3, so I'm going to put those into the missing spots, 1 and 3. And I'm going to go ahead and put those together. This is 4 plus 3, which gives me 7. So 7 minus 2z equals 5. Let's subtract 7 from both sides. So negative 2z equals negative 2. Divide by negative 2. So z now equals 1. And we now have all three of our variables. We have y, x, and z. Just make sure that you put them in the correct order when you say your official order triple. Has to be x, y, z. So it is going to be 1, 3, 1. That is our order triple. That is the solution to this system. Okay, number 6. Convert the following system into an augmented matrix and solve. So in order to write an augmented matrix, all of your equations have to be in standard form, meaning that all of them are in the form x plus y plus z equals a number. So looking at these equations, none of them are set up correctly yet, but we can fix them. So I'm going to call this equation 1, equation 2, equation 3. So with equation 1, x and z are on the correct side, so x and z, but y should have been somewhere in the middle. It's on the wrong side, so how can I get this y to move over? Anytime you're switching sides from the equal sign, you do opposite operation. So since this has a minus y, I could do a plus y, and that'll cancel. But same thing to the other side, so I'm going to write it up here on the top, plus y. So equation 1 would really just be x plus y plus z equals 2. And notice I put the y in the middle just to keep it alphabetical. So x plus y plus z equals 2. Okay, equation 2. 2y is on the left, so y is good. Our constant is on the right, so that's also good. But x and z, they were supposed to be on the left side, and they're on the wrong side. So again, you're going to do opposite operation. I'm going to do plus 2x plus 2z, and that'll cancel from here. But that has to go to the left side as well, so I'm going to write it kind of small here, plus 2x plus 2z. So equation 2, and we want to go alphabetical order, so I have a positive 2x. I have a positive 2y, so I need the plus sign. And then I also have a plus 2z. And then all that's left on the right is just this 4. We didn't do anything with that, so equals 4. Okay, and then equation 3. Negative 3x minus 3y minus 3z plus 6 equals 0. So x, y, and z are all in the correct spot, so that's good. But our constant, our number, it's supposed to be on the right, and over here, the constant's on the left. I need this 6 to move over. So opposite operation says that I would subtract 6, so we're going to do that from both sides. So our official equation 3 is negative 3x minus 3y minus 3z equals now negative 6. So now every single one of my equations is x plus y plus z equal sign constant. Now, it doesn't always have to be an x. Like as you can see, the last one has minuses. Like it doesn't have to be plus signs all the time. But as long as they're in that order, x, y, z equals constant, we're good. So now we're just going to take the coefficients. So the top equation is 1, 1, 1, 2. Equation 2 is 2, 2, 2, 4. And equation 3 is negative 3, negative 3, negative 3, negative 6. That is our augmented matrix. So that's the main part of what they were asking us to do, is to set up our matrix the way it's supposed to be. But our solution is just a calculator problem. I don't have a calculator here to show you, but this is the one where you type in RREF with parentheses, and then inside of here, you have to type in the matrix that we just came up with. So I'm going to call it matrix M, right? If this is M, you would put it into there, and it's going to give you another matrix, but it's going to have 1 on the diagonal. In fact, I know what this one's going to look like, so I'm going to write it here for you. It's going to go 1, 0, 0, 0. 0, 1, 0, 0, but then the bottom row is 0, 0, 0, 0. So normally what you're looking for is for the diagonal to have 1s, but this didn't work out. Like that bottom row, there should have been a 1 there, and there's not. So the other thing we check is, since the bottom row is all zeros, that means that this system has infinite solutions. Okay, and then our last problem, this one I'm not asking you to solve. We're just going to write the equations that match the system. So a farmer plants corn, wheat, and soybeans on a 240-acre farm. The farmer planted the same number of acres of corn as the combined number of acres of wheat and soybeans, and the number of acres of wheat planted was triple the number of acres of soybeans. How many acres of each crop did the farmer plant? So first, you should clearly define what the 3 things they're wanting you to find are. So see how it says each crop? So those are your 3 variables. And if the very first sentence tells you what they should be, corn, wheat, and soybeans. So you could use X, Y, Z if you like. In fact, that's kind of what I use most of the time. But I know on the test they use different letters, so I'm going to use different letters. Let's use C for corn, W for wheat, and S for soybeans. Okay, so right off the bat, they're telling us that his farm has 240 acres. So it doesn't matter if I do 0 acres of corn, 0 acres of wheat, and 240 of soybeans. Like all together, it needs to equal 240. So that's already our first equation. All the corn plus all the wheat plus all of the soybeans needs to equal 240 acres. Okay, then let's keep reading. The farmer planted the same number of acres of corn as the combined number of acres of wheat and soybeans. So anytime that I see the word same, to me, that means equal sign. So he did the same number of acres of corn. So corn is going to have to be equal to something as the combined number of acres of wheat and soybeans. So combined, when I combine 2 things, that means that I'm going to add. So they're wanting us to combine wheat and soybeans. So that's going to be W plus S. Corn equals W plus S. Okay, and then the last equation says the number of acres of wheat planted was triple the number of acres of soybeans. Okay, so number of acres of wheat. So we are specifically talking about wheat. So W is equal to. So was is kind of past tense of is, and that's also like another way of saying equal sign or same. Triple the number of acres of soybeans. So when you do something in triple, it means that you do it 3 times. So I need 3 times the soybeans, so 3S. Okay, and that's my system. So you could tell from this one, this would be one of those that's easier to solve by substitution, but we don't have to worry about that. They wanted us to write our system, and there it is. All right, guys, those are our example problems for today. I want you to do all of the practice problems on your own and let me know if you have any questions.